In today's session, Roberto will take us through Cloud Katana, Cybersecurity Fundamentals. Roberto is a principal threat researcher at the Microsoft Threat Intelligence Center Research and Development Team. And without further ado, I'll turn it over to Roberto. The floor is yours.
All right, thank you very much, Ashley. Let me share my screen and just making sure you guys can see it. Okay.
Yep.
Okay, cool. Well, thank you very much, everyone, for for joining this session. Today, we're going to talk about Cloud Katana. This is one of the first open source, I would say, cloud native solutions or just applications that Microsoft is releasing to use serverless computing to automate the attack simulations in your environment, with the main goal, of course, to validate your security controls. This is a very unique approach to attack simulation. We usually do a lot of it just by, for example, running a couple of scripts in our own computers, using our own identity to perform those simulations. So hopefully this presentation helps you, and it helps you kind of see the power of using all this, of course, from the cloud, and then, of course, using cloud computing and also Azure services. So like building cloud native solutions to run this in your environment. Once again, my name is Roberto Rodriguez, as Ashley mentioned, Principal Threat Researcher of the Mystic R&D team. I'm also the founder of the Open Threat Research community. This is a community used to encourage collaboration and also have other security researchers to help and contribute to other open source projects in the InfoSec community. And I also love docs and open source in general. And if you want to stay up to date with all these projects that we do for the community, you can go to OTRF, GitHub, the public GitHub repository of the Open Threat Research community. Okay, so today we're going to talk about Cloud Katana, what it is, why it was created, some of the design principles, like what are the ideas behind every single service or any single application that Cloud Katana uses. Also, we're going to show you how to deploy it, very easy, just with a couple templates, and also going through some demos to show you the power of using serverless computing to automate attack simulations. And of course, a couple of ideas in the future in case you want to help us to make it even better. Okay, Cloud Katana. So Cloud Katana, as I mentioned before, is a cloud native. So we're using services from the cloud, right? In this case, will be Azure. And this is going to be a serverless application. So we're using infrastructure from the cloud. I don't have to manage anything on my own locally. And this one uses Azure Functions. And I'm going to talk a little bit just about what Azure Functions are, and hopefully make sense just with a couple of examples. And we're trying to orchestrate attack simulation. So we're trying to take, for example, an end-to-end scenario and try to send it to Cloud Katana, and then Cloud Katana will just read the whole scenario and then execute one step at a time. Of course, once again, the main goal with this is to assess security controls, because we want to make sure that we are constantly trying to see what those detection logics are actually triggering on, and to maybe test all the way to mitigations in your environment. And of course, if you want to learn more about this, there is the link at the bottom in GitHub. And all this information, of course, will be at the end of this presentation as well. So why Cloud Katana? So this started just as a curiosity, just one idea, right? How can we start, automating things in the cloud? And of course, one of my main goals in my, so I would say position at Microsoft is to start learning about all these new adversary tradecraft, trying to understand what happens when you execute on a specific action in our environment. So I was just trying to figure out how can I just merge these two concepts of running something in the cloud to validate the security control, and then start using also serverless computing. Also, another topic that I was very interested in at that time, this started back in May 2021. So this year, we started with the idea, and then we decided to release it back in August, also 2021, through a conference in Las Vegas called Black Hat. And then at the end, we wanted to just expedite research, right? We wanted to make sure that we can use something that would just take all these obstacles that we were facing by trying to centralize all these actions in one place and trying just to create a mechanism to trigger actions anytime we want. And of course, at the end, we wanted just to define end-to-end simulations in a more robust way, trying to manage even the access to this infrastructure and trying to see who actually could run this in my environment. So at the end, all these, I would say, questions that we had at the beginning started answering a lot of the potential problems that we were having. So usually when you start a project, you try to define the problem, but for us was more just curiosity first. And as we were going through some of the process to see if we can improve some of our current solutions to simulate attacks, then we started fixing some of the problems that we have. So one of them, for example, the atomic versus compound simulations, right? We understand that atomic simulations, atomic tests, which means running one task, for example, and then just call it a day and say, this task generated this amount of logs, this task triggered alerts, and let's move maybe to another task that might not even be related. So that's very valuable, but we also understand the value of having chains of events or actions being executed in our environment. So we wanted to build something that would allow us to do these chains of events. Now, yes, we can do it once again directly from one script in our own computers. So we wanted to take that script and then just make it available in a different way so that we can use one centralized platform, and then we also can use one identity to execute all this instead of having all of us trying to build the scripts, chain a couple of scripts, and then use our own identity, or maybe create an account and then just pass a password to this script, which, as we know, is not as secure, right, to run a simulation. Because someone can find that script, take all these credentials, and then use it for something else. At the same time, we wanted to make sure that we can define simulations in a more declarative way. So rather than trying to focus too much on for whoever is trying to run a simulation, instead of just trying to rewrite a specific task, trying to put together code into one template and then run it, we wanted just to make sure that all these scripts, all these ideas, all these actions are already centralized, stored in one place, and we can simply call this action by saying, let's run this template with these parameters, and let's just chain all these actions and run a full simulation. So that was also very important for us to have this flexibility. At the same time, we wanted to use execution via web APIs, because once again, the problem that we were having was just running things locally. So why not just create this web API and then try to execute it from wherever we are with first trying to access with our identity, but then use the identity of the tool to execute all these actions. At the same time, we wanted to see if we can use cloud native solutions. So this is very important because the resources are usually limited while trying to build all this infrastructure, meaning, for example, even people to maintain all this infrastructure. We wanted to use solutions that we can simply call, start, maybe pay just for the, so I would say, time of execution, in general. So that was also something very important for us to make sure that we can use something not as custom that we can maintain, but something in the cloud, right? And at the same time, as I mentioned before, we wanted to have built-in authentication in this application and make sure that we can restrict the access to this application. Once again, rather than having your own scripts, your own identity, even your own, for example, Azure VM or your own endpoint where you can run things from. So we wanted just to have all this built in the tool itself. So all this took us to this design. So this is the first, I would say, Cloud Katana, kind of like the application, all the building blocks for Cloud Katana's application. And this is very interesting because we were not actually thinking about building this, but then after just going through all these things that we were learning, this is exactly what looked like at the beginning, and it is still the core infrastructure of Cloud Katana. So what we're going to do right now is trying to go through every single design principle behind it, and I hope that it makes sense at the end why all this was built. And also you're going to probably learn a little bit about all these different services that exist in Azure and how you can use all of them together to build something like Cloud Katana and then just automate attack simulations in your environment. So the first one, as I mentioned before, serverless execution. I did not want to worry about deploying and maintaining my own infrastructure. So this is the idea that we just want to send a request for an action to the cloud, and then have the cloud manage all this execution for us and just gives us a result back. So as I mentioned before, instead of running something locally, let's just take that script, right? Send it to the cloud, just keep it in the cloud, and then just run it directly from that, and then just receive the results. Something as simple as this is my input, execute something in the cloud, and just provide the output so I can maybe execute another action. At the end, we also wanted to group all these execution contexts into something that makes sense, like categorize all this execution. And of course, we use MITRE ATT&CK framework to start labeling everything that we can do with Cloud Katana. So it was an easier way, since we know the MITRE ATT&CK is becoming the standard, to label or tag any context in your security infrastructure, right? From detection logic, from alerts, etc. So why not also do that for Cloud Katana? So we wanted to make sure that we understand exactly what it is that we can execute or request, but at the same time share it with others and say, this is a persistence technique, a discovery, collection, etc. So at the end, it will look something like this, that we can simply send an HTTP request to the web API and then call for a specific tactic to a technique, and then Cloud Katana just executes the procedures or script behind this technique that we're trying to execute with Cloud Katana. And of course, at the end, Cloud Katana is what interacts with the resources that we're trying to execute this action against. Computation on demand. So this is at the end, rather than telling you what an Azure function is, with a couple of concepts in these past 4 slides. That's basically what Azure functions are in general. It's just allowing you to provide this like serverless solution where you can have computation on demand and allow somebody just to request an action and then have the Azure function take care of it. So that's pretty much our basics of serverless computing through a serverless web API. That's what an Azure function is. But now this is very interesting because at the beginning, this sounded like a really cool concept, and this is still a really cool concept. But if you want to execute an end-to-end scenario or a chain of events, an Azure function by itself is not going to be enough. We want to use an extension of Azure functions called Azure Durable Functions. And this is an extension of Azure Functions that allows the orchestration of multiple Azure functions. So you can actually have what is called an orchestrator and then execute a couple of pretty much what is called Azure function activities. And you can have multiple tasks being executed maybe in chains or also in parallel. So it's a very powerful concept from Azure Functions that we decided to explore, and so far is pretty cool to have the flexibility to orchestrate whatever we want to do or execute with Cloud Katana. And at the end, this of course allows us to start creating attack paths as code, because now we can have logic in an Azure function, which would allow us to then know which action executes first, second, or maybe something at the same time. So the way how an Azure function with the Azure Durable Functions work is that instead of having one Azure function, in this case, the basic concept would be what is called an HTTP trigger function, right? Now we make that concept just as part of multiple functions in one application, in one Azure function application. So we have an HTTP trigger that basically is going to be listening for any request of any attack simulation. That gets passed to an orchestrator function. This is the one that would allow us to know exactly how we want to execute or run some of these functions. For example, if I say, I want to run this action, but then maybe wait a couple seconds, maybe run this other one. And as I'm running this second one, I want to run a third one at the same time. So from the orchestrator perspective, there is where the logic gets executed. Then once an action is supposed to be executed, we run it with what is called an Azure Function Activity function. And this is the one that is going to expose all the code that we're trying to use in order to execute or define an attack action. For example, if I want to, let's say, grant permissions to an application, or in this case, update the credentials of an application, then all that code is exposed to the activity function, and there is where we define exactly how it is going to be executed. Currently, we're using PowerShell, but this could be any other language because, as we know, Azure Functions are language agnostic. You can have multiple languages executing through the same application. Okay, so this at the end, of course, as I mentioned before, allows us to have this stateful execution. That's one of the features of Azure Functions, durable functions. And what it means is that you're just simply handling the state of every action and how you can then use the output, for example, of an action and pass it to to the next Azure Function activity task. And you can just have an end-to-end scenario like this. For example, this is something that adversaries or threat actors have done in the past. And this could be, if you simulate this could be very simple to do with one PowerShell script, let's say locally if you want to, and you execute one action at a time. You say, I want to update credentials, I want to grant permissions, and then I want to access mail items from a specific account. Or you can have all this as part of an end-to-end scenario, and for example, allow Cloud Katana to execute one step at a time, and then maybe use the state of one action to pass it to the other one. So in the demos, I'm going to show you exactly what this means, but I just want you to think about this as there are two ways to execute this. You can do it atomically, one at a time, or you can do it as a compound simulation, where sometimes you can also use in this case, you can use the authentication context or security context from one of the steps in this case, right? So how do we handle now what's executing? What is the security context for Cloud Katana? So what I wanted to do first is try to divide so I would say identity for this application. First, we wanted to have us as security researchers to have some type of access to the application first, but then we also wanted to execute things with a total separate identity. So in this case, that way we can manage permissions. We can have only one, one in this case identity to execute things, and not have every single researcher in our team with like the same privileges as Cloud Katana all the time. So what does that mean? For example, if we just allow myself or somebody else to execute things in the cloud with their own identity, let's say that one of those actions requires you to be a global administrator or have maybe permissions to certain things that only high privileges accounts would have, then that means that I will have to allow my whole team to have those privileges. And as we know, that's not right, best practices. So we wanted to centralize these permissions on only one identity and be able then to focus only on that one, to be the one to execute things. So once again, there is one identity to access this, right? And there is another one to, of course, execute actions. And for this, we use a user-assigned managed identity. So this one allows us to be very flexible because we can also use this identity and maybe assign it to other resources that we want Cloud Katana to access, for example. So there are two kinds of identities: system assigned managed identities. This is the one where an Azure resource has its own identity and cannot be shared with other resources. And user assigned is the one that you can create even when the resource is not even available or has not even been created yet. So we create that one first, we grant permissions to that, and then we assign it to our Cloud Katana Azure Function application. So then that's the identity that starts interacting with other resources in the cloud. Now, so we do have this framework to orchestrate attack simulations, right? We have the serverless web API, and now we also have an identity to execute actions in the cloud. Of course, this identity needs permissions, as I mentioned before, in order to interact with other resources in the cloud. For this, so far we're using Microsoft Graph APIs. So this is going to be extended to other Azure services, but right now the proof of concept and testing just with Microsoft Graph. So what that means is that I could actually start granting Microsoft Graph permissions to my identity, and then I will be able to perform actions against resources which those permissions allows me to, right? So in this case, for example, if we want to, let's say, for example, so update the credentials or add credentials to an application. Then if we assign, in this case, the right permissions, the ones on the left, we can simply use our identity, so request this simulation and then allow the identity to interact with Microsoft Graph Services. And as long as I have the permissions to perform that action, I can simply, right, do it. So that's the basics of having an identity and granting permissions so that you can perform actions in your own tenant. Now, this is of course very interesting, and we're trying to limit the amount of permissions that we provide to Cloud Katana, only permissions that you need for specific services. Now, this is great. So we have, once again, something that we can use to orchestrate simulations. We can run things from the cloud, serverless, we have an identity, we have permissions. Great. But if we expose this in our own tenant, even if we have everything set up, so maybe that we can have only one link available for the serverless API, and then we can use that to request actions. That's not that secure, right? Because the link can just be leaked and then somebody will be able to access my application. The other one is to say, let's restrict this to only my tenant. And that makes sense, right? So now we say only people that are in my own tenant can actually access this Azure Function application. So in that first layer of security, from an authentication perspective, we are using Azure AD authentication. So in this case, what we're doing is we are first exposing the Azure Function application with an Azure AD application. That's, for example, starting from right to left, we do have the serverless API, the Azure Function app. Then we have an Azure AD application, which we're going to call a server. This is the one that exposes the application API, but at the same time enables authentication. So you will have to go through this application first in order to then get a token and then access the Cloud Katana Azure Function app. So the way how this works is you just request an authorization code to the authorized endpoint in Azure AD. Now, here is where there is all this interactive authentication happening, which means is that here you can have, for example, MFA, right? Here's where you have your username and password, etc. That returns an authorization code. This is the one then that you can send to the token endpoint. And then from here, you're going to get an access token. And then this token is the one that you can use then to interact with the Azure Function application. Very simple concept. And in my opinion, is start getting very robust from an authentication perspective, right? Rather than just have your Azure Function app sitting in your tenant and maybe creating just one URL that everybody could use, right? So now we have some layer of authentication. But at the same time, of course, anybody in my authentication, in my whole tenant can actually authenticate to my Azure Function app. So we want to also understand how we're going to handle authorization for Azure Function, for Azure Function applications that make Cloud Katana. So in this case, what we can do is say, let's have a security group that only people in this group can actually go through this whole process. If you're not part of this security group, then you will pretty much not be able to even interact with the authorized, for example, endpoint in Azure AD. So that's the way how we are handling the authentication process, but also the authorization process of Cloud Katana. This is also for us was very interesting to use only built-in authentication, I would say, services. So we don't have to create our own process or code the way how authentication is handled by Cloud Katana. So that was one of the design principles as well. Let's make sure that we use cloud native services, something that we can just use that might be built in with, for example, Azure Function applications. And that's one of the features of Azure Functions, direct integration with Azure AD or any other authentication service that you want to use. Okay, so once again, so I'm trying to make sure that we understand exactly what we're doing. So we have the web API, serverless API, we have an identity, we have permissions. Now we are securing the access to our application, and we're also understanding that we can use Azure AD, for example, as our built-in authentication service to allow anybody who wants to access this go through the whole process, right? So now, how do we document our actions? The things that we're going to execute against our own tenant, for example. So there is a couple of things that we're doing this. First, we are documenting every single action as a YAML template, through a YAML template. So in this case, as you can see on the right, we have a couple of templates, is one template per action. And we're trying to add a lot of metadata in these templates. So this is a basic YAML file. On the top, you can see just basic metadata. We're actually mapping things to MITRE ATT&CK. We are defining also what permissions do I need for this specific action, and also what is the resource that I'm trying to use for this action from a permissions perspective. In this case, would be Microsoft Graph Services, right? At the end, we're also adding parameters. So we want to understand exactly what it is that we want for this action. So let's say this action requires an access token. This action requires maybe the name of an application, maybe requires a service principal ID. So we want to make sure that we define this. And then, as you can see, we're not defining this in any specific language. And this is because we want to keep this language agnostic. At the end, we can have a section that says scripts, and then we can point to the specific script that is going to run the action that we want. So this, for example, in this action, we're trying to get or read mail from a user. So we define everything on the top in a whole YAML format, and then we can point this to several languages on how I can accomplish this. So I'm pointing to that script, and that script is just a basic PowerShell script that is using Microsoft Graph, and then it's just invoking a HTTP request against Microsoft Graph, and then just calling for a specific action. All this can be written in Python, so you can also have this in a different language. But currently, we're using PowerShell as our main language to execute code and be able to interact with other resources. Okay, so now that we have the code centralized in its scripts, right? We have it all documented. Now we want to call this code, right? We want to call this execution. From a client perspective, so from the user that is trying to define a specific action to execute through Cloud Katana, as you can see on the left, a simple action can be defined as a dictionary. So you can say, I want to run the Azure activity function, right? This is just one atomic action. The name of the action will be, let's say, add passwords to your application. And these are the parameters that I need. So this is the input. I need the ID, the object ID of the application, and I also need a display name for this password or for this credential. So when you see it in your portal, it's going to have the name that you wanted, and then, of course, a secret text. As you can see, we're not defining the code. All we're saying is, I want to run this with these parameters. That's what we would call declarative ways to define actions. So we don't have to worry about the code. That's already centralized and is stored in Cloud Katana. A workflow is a combination of actions, right? As you can see on the right, we have multiple dictionaries as a list, and we can start chaining all these actions. For example, on the left, the second action in this list, we say add credentials to an application. Great. That's going to provide a secret text the moment we execute this. It's going to be a new secret text, a new password for a specific application. But then in my next step on the right, I say I would like to request an access token with the new credentials that we added to the application. That way, I can start interacting with my own tenant as if I was the application, right? So getting an access token from the application, and in this case, I want to use the secret that I created in the previous step. So that's how we start chaining the output and input of our actions here in Cloud Katana. And this is called a workflow. And this is, of course, a data model that we're also documenting and creating so that we can make it public, so we can make it open source, so anybody could use it. So we are currently testing the way that this data model will look like. So then at the end, if we want to finish this simulation, so once we get the token, then we can use that token as part of the next step where we can start reading mail with the security context of the application which we added a credentials to. And that would be my end-to-end scenario, something that I show you previously as how you can execute things atomically and also as a compound simulation, for example, so multiple actions. And so Cloud Katana receives this template, and then the orchestrator will start executing one action at a time, for example. Okay, so one of the last concepts is programming language agnostic, or just simply language agnostic concepts in Cloud Katana. So we have two sections where we can have multiple languages. So first, on the right, we know that Azure Function applications, you can run things with Python, PowerShell, .NET, etc. Right? So you can actually rewrite all these steps that we're creating in different languages, and you can just create a new Azure function with a new backend that will handle those languages. But then at the client side, we can have also multiple languages, as long as you can handle the authentication process with the Azure Function application. You can use Python, PowerShell. There is a couple of libraries, for example, such as the Microsoft Authentication library, right? And if you want to use even something as Jupyter Notebooks, you can have multiple languages as well as the client. So you can start interacting with the Cloud Katana Azure Function application, and you can just choose whatever you feel more comfortable with. So different places where you can make it very modular and interactive. Okay, so now we get into the section of what are the things that we are now testing. We're not sure if this is going to be part of Cloud Katana, but we want to make sure that we also cover other scenarios. So all this is being done, it is pretty much under development. So if you have a question, please let me know. There's a couple of things maybe that don't work with some scenarios. So we're trying to see exactly what it is that we can add to Cloud Katana to improve, in this case, execution, also on on-prem endpoints. So what if you have your hybrid environment where you do not just want to execute things against Azure resources, you want to also execute things against, for example, your domain controllers on-prem or your own endpoints on-prem. So we have two tests going on. One is through the Azure App Service Hybrid Connections, and then the other one is using basically hybrid runbook workers. And once again, all these concepts, right, we're not going to go deep into this, but it's just a way for me to share some of the Azure services that if you start reading more about, it opens a door to several other capabilities for attack simulation. So the homework after this webinar is to also go deep into all these services so you understand even additional things that I might have not been considering. And if you want to contribute, please let me know. But there is just a lot that we can do with all these services. And putting all this together as Cloud Katana, it's been a great learning experience to understand exactly why I need all these services. Okay, so test one pretty much looks like this, where you have an Azure Relay. This is a service that allows you to communicate with an on-prem device, and you can have your Azure, for example, function application or your Azure functions triggering things against the on-prem endpoint. And this one is going to use the hybrid management agents on the endpoint so that you can start exposing that endpoint to your Azure function application. So at the end, it's going to look something like this. For example, this is an Azure function PowerShell application or just function. So as you can see on the function, I am defining some PowerShell code, which is going to be executed against a endpoint on-prem. And I'm simply saying, for example, in this case, let's go to GitHub, download a project that would allow us to dump credentials, in memory. And then we're just simply running this. So on the right, on the black terminal, we can simply say, let's request this simulation to Cloud Katana. Cloud Katana runs the code, interacts with the endpoint, and then sends all the data back to the client, where this was requested from. So as you can see on the terminal, we just requested, wait, and then we get all the results back. So that's the testing that we're doing so that we can add things also on-prem. But of course, this has a lot of limitations, and one of them is at the bottom, supporting, for example, Active Directory, right? Because you cannot join a service, worker. So what that means is in this image, for example, we cannot join the on-prem device with the agent install. So we can define a couple of credentials, like username and credential, to run this execution to access the box, but we cannot do more from a domain join environment, right? So this is something that we believe it's interesting, it's pretty easy to set up, but maybe it's not going to help us as much. So what we're testing now, and this is something that it's new, it's actually using, as I mentioned before, hybrid runbook workers. And we're doing the extension-based workers. So what that means is that we're now going to require, for example, like log analytics agents installed on endpoints. And then we need, of course, like log analytics workspaces to handle and track all these jobs or executions. So the way how this works is we need an Azure automation account. And then we have all these runbooks that then we can start executing on on-prem, for example, endpoints, or also on, let's say, Azure VMs in our own resource groups. But then this automation, these runbooks, can be executed directly from the Azure function. So this is a very interesting approach, because in this case, we can actually start running actions against domain join endpoints, and then it will be very flexible for us to start executing things where, for example, a domain feature will, be needed, for example, in these scenarios. So something that we're testing is not ready yet, but this is definitely a very interesting approach for attack simulations, using, of course, once again, cloud native services built in and being triggered by serverless computing through a serverless web API, right? So there's nothing built on my local computer. It's just all pure chaining services to make these simulation concepts happening. The last thing that we have is knowledge graph as well. So after we have all this framework, what can we do with the data? Yes, you can simulate things, you can trigger alerts, but you can also start maybe enriching some of this data that you get back. For example, if you do some type of recon activity, right? If you collect all the directory roles or groups in your environment, such as a global administrator group, and you also have the members of this group, you can actually start creating some basic graph concepts where you say this user that is a global administrator, it's also the owner of this application and then these other things. So you can create a graph knowledge, I would say, library of your own environment. So why not also empower that use case? So in this case, what we're doing is we're using Azure Cosmos DB. And the concept in here is that what we collect from Cloud Katana, specific modules, can be sent to an Azure Cosmos DB, and then we can use Gremlin APIs in order to query this data. Now, I use PowerShell, so of course there is not a PowerShell module to interact with Cosmos DB from my Azure Function application. So in this case, we're using gremlin.net to then translate .NET libraries from Gremlin, official libraries, and then make it a PowerShell command-led class, so we can run PowerShell commands and leveraging Gremlin APIs from its .NET library. The way how this works, just very, I say very simple, but it took me a few hours to figure out exactly how to do this, because I'm not that good at translating .NET to PowerShell. But in this case, we're simply using, in this case, trying to get the .NET framework class library, for example, 4.7. We are installing the Gremlin.NET library, and then we're just running C# code that is going to create our PowerShell module with specific functions that I could use. So at the bottom, as you can see, this is going to produce a DLL. I can import the DLL, and then I could use a PowerShell commandlet, which is built from the .NET class or library. And all this is already packed, so you don't have to do anything. I'm just telling you exactly how I build this, and there is a lot of links that you can use to understand the ins and outs of this process. So at the end, for example, I created a couple of functions. So let's focus on the top one. The top one says, give me all the Azure AD directory roles. So in this case, one of them could be a global administrator, right? Then I have another one that says, hey, can you take all these roles and get me all the members? So now we have all the global administrators in my environment. But then I could do this across all my directory roles, right? So those are two functions that I have. And this is great, but it's just maybe a lot of data. So how can I query this, enrich all this data? I have another function now, it's called invoke attack graph. And this one goes through a lot of services, not just Active Directory roles. And then I can start packing all this information. For example, vertices or nodes, it would be the directory role, global administrator. Edges would be global administrator. We do have this member. So let's say, Roberto belongs to the global administrator role, for example. So we can start also crafting this in a way that we can use it as a graph. So at the end, if I just push all this to Cosmos DB, and this is done by the Azure Function application, then I can start going through this data in a graph way. And we can start showing, maybe do it manually, going one by one and exploring the connections between all this information, or I could simply run a Gremlin API graph query that which will give me some interesting scenarios or interesting attack paths in my own environment. So this could be used, of course, for the simulation itself, but I would use it for a more defense capability so I understand what my attack paths look like in my environment. Okay, so that was pretty much everything that we're currently packing in Cloud Katana. So many different services, so many things going on, but I hope that this step-by-step of explaining exactly how everything fits made sense. All this information is also part of the website of Cloud Katana, which I'm going to share in a little bit. And this is going to grow. There is a lot of things that we want to do and start building on the top of this main concept. The deployment is very easy. If you go to the website at the bottom, cloudkatana.com, and there is a way to deploy these through an ARM template, this will expedite, I would say, 90% of what you need. Then you might need to do a couple of things manually, but most of the core infrastructure is just created by an ARM template. And you can go through all the steps, and it's very easy. It takes only, I would say, maybe 10 minutes to deploy all this, and you will be able to have a serverless API, which you can use to authenticate with your own identity. Of course, as long as you added your identity as part of the group that it's allowed to run this application. You can monitor your deployment. You can see all the resources being created once you run the ARM template. And as you can see, this is creating the Azure Function application, the identities that you need, and is running a couple of PowerShell scripts to go through the process of creating all these resources. At the end of the day, you can also explore what's going on. So you can have, for example, the grant graph permissions action while you deploy it. And you can see that this one, for example, is going to grant all the permissions that are required for all the attack actions that you can do or execute with Cloud Katana. Since we documented every action with what permissions I need, then I can just aggregate all those permissions, have a unique count of all of them, and then just to start granting all the permissions that I need for all the simulation attack actions that I want to do. You can then get into the functions resources being created. As I mentioned before, we have an HTTP trigger, we have an orchestrator, we have an Azure function, which is the activity function. And as I mentioned before, this is the one that will expose PowerShell code, something that is going to be executed by our Cloud Katana application. All right, so let's get into the demos. So we have a couple things going on in here. So there's going to be one scenario executed in two different ways so that you understand why we are maybe over-engineering this concept. But there is just a lot of things that make sense to, for example, use Azure Durable Functions. So in the first one, so what we're trying to do is first, we're going to grant permissions to an application. Then we're going to add credentials to the same application. And then we're going to read messages with specific permissions that we granted either to the application, but in this case, we're saying Cloud Katana has permissions to read mail, so why not just do that? That's because I want to show you what an atomic action will look like, where you do not use the output of other actions to perform your next action. We're just saying we want to grant permissions, we want to add credentials, and read mail. That could be 3 different alerts that you might have in your environment, okay? So what about the second scenario? This is a workflow scenario. Here's where we say, for example, grant permissions to an app, add credentials to the app, then request a token with the security context of the app, by using the new credentials, the secret that you added, and then using that concept, like the application itself, the access token, then read mail. So there is when you can actually start thinking that when you run a compound simulation or workflow, there are going to be steps that will depend on each other, and that will be a true chain of actions and not just simply running one action at a time. And sometimes those actions don't have a direct connection between each other. So we're going to show you how you can run one with multiple requests to Cloud Katana, and then just one request directly to Cloud Katana with everything. Okay, so let's just run this video. So in here, we have a concept, once again, a single action and a workflow. And in the single action, first we need to import our Cloud Katana module. That one has just a few functions that expedite this process. Then we have an application for the atomic simulation, and we have another one for our workflow simulation. As you can see, this one only has one permission, right? Which is the user read permission. This is an OAuth application. And then we also want to add credentials to that. So in this case, we can see there are not secrets that were added to both applications. One is for the atomic, one is for the workflow scenario. And we do have the orchestrator. And this is constantly listening to what's going on in this environment. What are the executions that I'm running? First thing, we need to get a token, as I mentioned before, authenticate to the Azure Function app. In this case, we use the, for example, username that we assign, and we say, this is the one we're going to use to authenticate to Cloud Katana. Then we get that token and we make it part of the authorization header of our next request. And this is where we start now defining a basic action. We want to grant permissions to this specific application service principal ID. We want mail read permissions. So we just define this in a dictionary, and then we send that to Cloud Katana as an HTTP request. If we look into the orchestrator logs, you can see that there is some permissions being granted, and we can then explore the results by just querying Cloud Katana again and saying, give me back anything that happened after this action. And as you can see, there was some assignments of service principal for permissions. And if you refresh your application, you can see mail read being granted to your application. Second one, we want to run the action to add credentials. We're just giving it a name, and we do the same thing. We just send this request, this dictionary, to Cloud Katana. And if we look at the orchestrator, we can see that there are some credentials being added by using the credentials graph API, for example. And then we can just request for output, and we can see the secret being added to this application. And of course, as we know, if you go to the portal and you just refresh this, most likely the secret is going to be hidden, so you won't be able to use it. But Cloud Katana captures that and then can use it for something else. In this step, we're just simply reading mail from the GA, from the global administrator in my tenant. And then I'm just saying, Cloud Katana, read mail. I don't want you to use anything else. Use your own context for this. And then Cloud Katana will use APIs for Microsoft Graph, and it's going to just dump all the mail from a specific account in my own tenant. And that's it. And then I can just go through the results. And in this case, the output is going to be multiple dictionaries, like multiple information, multiple objects that we can access. One of the attributes or properties of the objects is just the subject, the title of the email. And that's it. So that would be just running just atomic actions with Cloud Katana. Second scenario is the workflow. Same concept. Let's just get an access token so we can interact with Cloud Katana. And then instead of running one step at a time, in this case, we're just setting the authorization header. We're simply saying, let's just give it a template, a similar template that I showed you before, which was a JSON file with a list of dictionaries. In this case, as you can see, this template does have a couple of variables. You can see there is a password credential name. At the bottom, there is another one that is the specific user that I want to read mail from, right? The user principal name. That's just a variable, right? So in PowerShell, we can use a concept that would allow us to substitute all these variables. First, we define them locally, and then we just set the invocation context. And we expand these strings, and then we can just now have our JSON object with all these variables now that are substituted by the specific values that I need. I send this JSON object, which will be my template, and then Cloud Katana will take the template, will recognize that it's a workflow, and if you, for example, refresh your application, you can see that mail read was granted. You can see that there is credentials also being added to this other application. And then, of course, the last step is to take these credentials, get an access token as the security context of the application, and then read mail. The output of a workflow is going to be a dictionary where the keys are going to be the name of the steps, and then the values, of course, are the output of every single action. So if I just check the output and I check the get mail box messages action results, then I can actually get to the mail that I was trying to obtain as the application that I granted or added credentials to. Granted permissions and then added credentials to. And same output, right? We can actually read mail because we granted application permissions to the application. And that's it. And that's how I would say easy is to run the simulation attacks atomically and also from my template. For the future, there is a lot going on. So if you want to contribute, if you have any ideas, any questions, please let me know. Let us know in general through the Cloud Katana GitHub repository, for example. You can open an issue. But overall, just to summarize this, we want to improve the on-prem, right? The hybrid execution. We want to have reporting capabilities. We want to also add an Azure static web application so that we can make this interaction with the tool easier and not just through a Python or PowerShell client, for example. And then, of course, improve our graph knowledge capabilities as well. That to do, right, what it is that I want you to do once you go back home or you start your day today is deploy Cloud Katana, right? Learn a little bit about Azure Functions in general, and then share those ideas with us. We would love to hear what of those scenarios that you would like to simulate as well. There is a Discord server for this because we also have the community, the InfoSec community that I built, that I created through the Open Threat Research community. So you can go to a Discord channel, and we're happy to talk to other members or the other members of the InfoSec community if anybody has any questions about Cloud Katana. Thank you very much for your time today. There was a lot that was shared today. But I hope that this was helpful to understand the concepts behind Cloud Katana, what it is that you can do, and how the identity, the execution, how everything is defined, and of course, all the possibilities that this, I would say, attack simulation framework to validate security controls, has at the moment. And if you want to follow me on Twitter, once again, my handle is CyberWarDoc, and I hope that this was very helpful. Thank you very much.
Thank you, Roberto, for the excellent presentation and for being our guest today. Let's see. Looks like if anyone has any additional questions, you can ask them at aka.ms/SCI community. And at the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/security community. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We'd love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you and see you next time. Goodbye.